Andre and Alejandro are long-term members of SATURN. I've seen them over the years. Andre is a professor and a researcher at UNICEN University in Argentina. He is also a software architecture consultant, offering services in specifically in SCI methods, where he worked for the SCI for about 3 or 4 years before his current affiliation. Andres holds a PhD in computer science from UNICEN University, so it seems like you went back to your alma mater. Great. Alejandro Bianchi is the president of Liveware. I think you're giving us an experience report from your company. He has over 30 years of experience in software improvement, process improvement, and software architecture design. He holds a bachelor's degree in information systems, a master's in strategic management, and a bunch of certification from the SCI, namely the ATM Evaluator and the SCI Software Professional Certificate. So welcome, Andres and Alejandro.
It's better? It's better. There you go. Yeah. Well, thank you for the introduction. My name is Andres, and I will do this presentation together with Alejandro, that also was already introduced. And this is basically an experience we are going to present about the use of different architectural methods in combination for a specific project for a company in Argentina that is basically a government company that does some research and development stuff, like radars and monitoring system for radars or for air traffic, basically for Air Force. And so we in this context, what we had to do was to adapt this kind of method to this specific domain, as I will show you in the slides. So very briefly, the items I'm going to talk about are basically the context. I will say something more about the context of this company and the main problems that we're facing in this particular project. Then I will describe the solution, this architecture-centric solution that we propose to solve or to deal with those problems. Basically, we apply different methods, and we created a reference architecture for this domain and for this customer. And then I'll move to some lessons learned, some insights, and wrap up with the conclusions. Something I was forgetting. I'd like to mention that due to some confidentiality agreement with this customer, where some part of the presentation cannot be disclosed, or some information has been changed a little bit for this presentation. But anyway, I'm going to show some examples and some pictures of what we did with the method, so that our points are clear, are more clear to the audience. So, and then the domain for this company is basically, as I said, ground radars. So they have different types of radars. We capture different kind of information, have different configurations, different hardware, and different protocols. And so it's basically a lot of system stuff in this company. But they have also some software component that they call it Mimico, that is its name in Spanish, but basically it's a component that gets all the data that comes from the radar, that then comes to the software system every 10 seconds, where the frequency sometimes changes depending on the specific type of radar. So this Mimico system gets all the events from the radar and do some processing on the data and triggers some alarms. Well, all this information is called telemetry, and all this telemetry is presented in some summarized way, like an overview, to a human operator. And the main thing of this operator is that he doesn't know much about the internal working of the radar. So this operator will trust the software as if it were the real radar. So that's an important kind of quality aspect in this system, because if there's something wrong with the radar, this operator can go quickly to some other chain of command and report the situation, but he doesn't have a detailed knowledge of what is going wrong with the radar. So there is also another user, that is the system maintainer. When these problems come up, it will go to the radar and will read all the variables and try to produce a diagnosis of the problem. So, but basically this Mimico system is oriented to the standard operator of the radar, not for the expert. So the desired qualities of this kind of system are, as I said, fidelity in terms of capturing as real as possible and as timely as possible all the information that is entering to the software system from the radar. There are some performance consideration. It's not a real time with tight deadlines, I would say, but it has to, if you have 10 seconds to refresh all the information, you have to produce and process all the information in less than 10 seconds, and these values change depending on the technology. And it also needs to have a way to facilitate the diagnosis of problems. Those are like the main qualities that they expect in this kind of Mimico systems. Regarding the organization, basically, this is an organization with a wide pool of stakeholders, mainly in the system domain. So they have physicists, nuclear engineers, system engineers, electronic engineers, and some software guys. And as you can expect in this kind of context, developers are not always perceived as the first-class kind of stakeholders, because they say, okay, all the complexities in the hardware, and then you, the developers, you have to do some easy task to show information into the screens. So, but nonetheless, the management in these kind of companies know that the software layer can add more value to the organization and to the product. So what they are trying to do is trying to reinforce the role of software developers or software engineers in this kind of organization. So they have this Mimico system running. When we were brought into the project, they already had a version of the Mimico running. And this system was a brownfield development, and this system was built actually by a contractor, and the system was doing okay. It was meeting all the functional requirements of the specification, but they started to have some problems, some quality problems, and some maintenance problems. And since the relationship with this kind of contractor didn't end well, because this organization was, I would say, kind of immature to manage the relationship with this contractor, they had the software in place, they have the code, they have some documentation, but in particular the design documentation or the architectural documentation or the main decisions that were made for this kind of code was lost. So this is a typical scenario in many organizations. Pretty much in this diagram here is a CNC diagram. I have some of the main components of the system as it was before this restructuring. I mean, the organization was trying to apply some refactorings on the system and improve the quality problems, but at some point it wasn't enough. So, for example, they have all the telemetry in a repository with a database, and they have some drivers written in C that would get the data from the radar and would store them in the database, and they also have some business rules for processing the data that were written in JavaScript, and then all this data was presented to the users using the Qt framework. Basically, they use JavaScript here because they need to prototype different business rules quickly. I mean, the developers were constantly interacting with the system engineers, and they say, well, for this new radar, I need this kind of processing, so could you do it quickly? And they would go to the business rules and would change something. As you can imagine, the maintenance problems could come from this part of the system. They also, another decision that made was to move the database in memory because they started to have performance problems. But the solution didn't scale well, so at some point they realized that they were having a problem that was beyond this design. It was more like they needed a more general solution, and basically they were creating Mimicos for different kind of radars with different technologies. So at this point, it's the point when we engaged with them, and Alejandro was having some conversations with the managers, and it was clear that they needed like an architectural-centric approach for this kind of system, not just for the Mimico, but for a family of Mimico systems. And also, we wanted to achieve other goals with the architecture, like speeding up these development cycles and this interaction between the developers and the system engineers, but without sacrificing the quality of the design. Also, we needed a model to engage this pool of stakeholders and to discuss their concerns are the quality issues without going into the details of the code, because these electronic guys would say, okay, don't show me the code. I'm not going to go through that. I just need to discuss problems from a high-level perspective. And also, they needed to empower a little bit this new software division that they had, because they have a limited personnel. So we started to do some consulting on this aspect as well. So specifically, what we proposed to do here was to create a reference architecture for the system in order to enable a systematic reuse of some of the domain knowledge that they already had, so that they knew a lot about radars. But also, we wanted to put this knowledge into reusable asset and try to create some kind of product line for the system. And also, we wanted to use this reference architecture as an artifact to share the design decisions, to communicate design decisions, and to have some discussion on which design decisions were the right ones for the system they were building. Well, in the end, we created the reference architecture, but for the product line, we had some ups and downs, so this is still an ongoing activity. Specifically, our strategy, our architectural strategy, applying the architectural method was as follows. We had three main activities based on the SEI methods. The first one was to identify the business goals and the main quality attributes or quality attribute scenarios for the system. And we did a QAW. This activity was performed on customer side. Liveware is an Argentine geography, is based in the capital, and these guys were working like in the south of the country. So we had to manage the interaction remotely, or most of them at least. Then we moved back to the capital, and we started to create a reference architecture using ADD, and we needed to produce some architectural documentation for this solution because that was part of the contracts. They didn't want it to lose, again, the architectural knowledge of the system. And in the end, we wanted to make sure that the architecture just created was as good or good enough for the quality attribute drivers. So we performed a kind of evaluation based like in ATAM fashion. It was not a standard ATAM, but we did an evaluation with all the stakeholders. This was also on site on the customer side. And also we were asked to provide some technology guidelines for restructuring the system, but this technology assessment or these options for implementing the system should be aligned with the quality attribute drivers. And in the combination, we had to make some adjustments and tailoring of the methods, as I will explain in a few minutes. So as regarding the team, we had this quite small architectural team. We're three people on the Liveware side for doing all these activities. On the customer side, we got some of the developers that participate in the whole project and a technical liaison who worked with us remotely. And this picture shows how we planned the schedule, or how we did the scheduling of the activities. As here you can see first the QAW, then ADD with 3 iterations of 3 weeks each. And then at some point with the architecture was expected to be mature, we did like a big evaluation. We have some evaluation instances in here. And then in the end, we have to deliver the documentation. But actually, we started to create documentation here in the middle of the ADD process, mainly using a case tool, Enterprise Architect, and some notes. So, but at this point, after the evaluation, we collected all the findings and we produced it like a deliverable software architecture document. And as I said, the whole project was planned in a iterative way because, I mean, that was a requirement also from the customer. And currently today we are at this point in time, but we are also doing some prototyping of a new system based on the results of the evaluation. So, okay, let's go a little bit into the details of each of the 3 main activities. Let's talk first about the quality attribute workshop. We started here identifying first the business goals for this company. They knew the business goal, but they weren't written down anywhere. So we found it was useful to clarify that part first before going into the quality attributes. So for example, we provided with some examples of canonical business goals. And after one morning discussion, they come up with some business goals, like reducing time to market or facilitating the monitoring of the radar for the operator and that stuff. And then based on these business goals, we started to generate and do brainstorming of possible quality attributes scenarios for the system, like, I don't know, 20, 25 raw scenarios, and then we did a consolidation and we established some, together with the stakeholders, we established some priorities. And so we had some of the expected kind of quality attribute that I mentioned before. The one in colors here are those who got the highest priority. And then with all these scenarios, we started to do the design work. But before going into that, since remember that this was a brownfield development, so they already had an architectural plan and actually a system that was supposed to be good for their goals. So what we introduced was a new activity that basically we perform a risk analysis of the architectural plan and the kind of asset that they already had in place. And in this exercise, that this is a customization of the standard QAW, we started with a conceptual architectural blueprints of the system they already had, with the main components like the UIs, the core with the business rules, the repository, and the drivers. And what we did was to put all this information in a graphical sheet like this, and we had all the scenarios with the stakeholders, all the priorities, and we started to analyze each of the cells. I mean, how the scenario would impact on the different layers or tiers of the system. And here, basically, red means that the scenario is not satisfied by the current solution, or it is implemented, but it has serious problem in achieving the quality attribute. Yellow means that is satisfied partially, or it needs to have some modifications. And then you have green, that means that the scenario as it is satisfied by the current implementations. You can see here, for example, for the top 5 high priority scenarios, it's all in yellow, so it means it could be satisfied with the current design with some modifications. And even for some of the drivers that they had this code, we thought it could be reused in the new system. So this exercise was interesting for the stakeholders and for the management, because they were pretty shocked by this result. Say, okay, but we had a good system, but then looking at this table, we say, well, it was not as good. And basically what we discovered is that they were thinking like short term, like looking at the next version of the system, and weren't looking at the family of products. So, and we were kind of pushing the architectural solution to, in a long term, trying to support different kind of mimicos. So already said this. We detected some other problems, like performance issues with the processing pipeline for telemetry, or high coupling between presentation and business logic. So with all this information, we started the design of the solution. It was, as I said, an ADD exercise with 3 iterations. We allocated around 4 scenarios per iteration. Actually, we had in the team, one of the members of our team had a lot of experience in SCADA systems, so that he knew how to deal with some of the implicances of this kind of design. So we were confident that some of the quality attribute drivers were feasible, at least from a technical point of view. So that's why we said, well, 4 scenarios for an iteration should be okay. And we also used the scenario as an evidence, or as a means to conduct reviews with the client and to show them the progress in the design, because remember, we were remotely located, and also to show progress. So after each iteration, we had a session, review session of all the decisions made, and we got all the feedback from the customer and trying to adjust the work in the next iteration. And this proved to be very useful, because when we went to the final evaluation, we already had some initial rounds of internal evaluations that could show us which the problems were. When doing the ADD design, as I said, we use Enterprise Architect to have even the information of the scenarios and some guidelines for using. We provide them with some guidelines for using all these vocabulary of UML and no UML elements. But the most important thing is we explicitly capture the design decisions in this kind of diagrams. So then after 4 months, we had enough confidence in the architecture and enough information to go to the big evaluation phase. So what we did here was we went to the customer side with all the stakeholders that were present in the QAW session, plus a few new stakeholders that show up. That was an interesting thing. And we review all the scenarios with them. We did a walkthrough with implicancies of all these decisions that we made for the system. As I said, this was not a standard ATAM exercise with phase 1 and phase 2. Rather, we performed the design evaluation, but the difference was that this time was performed with a broader stakeholder audience, and also we have an in-depth discussion of the issues and all the consequences. And we still use the ATAM template to capture all the findings of each scenario. And here, after 2 days of evaluation, we presented a preliminary report to the managers about the results. And also here we use another graphical metaphor to show the results of the trade-offs on the architectural blueprint. So this is like pretty much how the final architecture looks like a blueprint. And then what we did in order to facilitate the stakeholders' reasoning process about this trade-off was to map different trade-offs on the architecture. Like here you can see the main problem or the main trade-off that they have with the processing pipeline and the interactions of this trade-off with other trade-offs that we found in the evaluation, like for example, modifiability or usability. And with this trade-off, we had some risk associated to some of the trade-offs. And also we had some risks that didn't come from the trade-off that actually were brought in by these new stakeholders in the meeting. So we have new issues that wasn't taken account into the design work, and we have to deal with them and decide if it was going to be part of the scope, out of the scope, if the current system could accommodate those. So this is, as I said, the new system was actually a big difference compared to the system that they had already. What they got was a better capture, I would say, of the architectural knowledge, the main decisions, the documentation, the quality attributes that were important for them, and the analysis of each of the quality attributes. So we ended up creating like a 40-page software architecture document that wasn't that big in the end, but still compared to the 4-page design memo that they had in the beginning, it was a good contribution. Also, we provided some recommendation for the technology, for example, using a broker or using a database for the solution but this time they were able to discuss these technologies in the context of the architectural solution. So the main lesson learned for this project were basically we achieve a conversion of the stakeholders through the architecture. For example, this interaction between the system engineers and the software engineer was achieved through the architecture, and we heard phrases like, we should do this workshop for other products as well. So they were very enthusiastic about it. Also, this aspect of using scenarios across the development to measure progress and to engage them in reviews, and also the use of the architecture as a way to see a long-term vision of the product, not just as something that will provide a solution for the next product. We found out that it was pretty useful for them. There were some drawbacks, like for example, we didn't have enough functional information to create this architecture. So at some point in the design, we needed detailed information for the interfaces. And so we couldn't get that. The architectural reconstruction that we envisioned, for example, for mining existing asset, didn't go that well because of the scripting that they were using. So it turned out that it was pretty difficult to extract relationship between the components in the Qt framework. So I'm still working on it. Just to summarize, we believe that this kind of experiences was very useful for the organization, and we show them the need to use this method in combination and to articulate them to the specific needs of this market, of this customer, and as a result, they are now envisioning new product, new kind of mimicals, for example, for medical devices using this approach. We also would like to highlight the importance of having visual metaphors or graphical visualizations for managers or for other people in the stakeholders group to understand the consequences on the implicancies of the architectural decisions. And as I said, now we are going through a development of prototype based on the ATAM results. Like if you can take a template of ATAM and you have all the analysis of a quality attribute, and then you can put that into a working prototype. And as a last comment, Another thing that comes out from this experience was the need to have some kind of measurement framework for architecting activities. That is an objective that Alejandro has been after for a while, and we think it's very interesting in this kind of architecture-centric development methods. Well, that's it. Thank you very much for your attention, and happy to take any questions you may have.
Okay, thank you, Andres. Any questions? We have time for a few.
You have developed reference architecture. What type of reference architecture is it? It was special for this radar system, or what? How can you gain this reference architecture?
Well, yeah. If you look at the documentation, for example, this software architecture document that you produce it in the end, it looks similar to a normal architecture, but it had some features into it that would support different products. For example, we had all the main decisions, we have all the main deployment options that you can have in this kind of system. For example, this is not the option I show here in the architecture is not the only deployment configuration you can have. And also this architectural document included some hooks and some variability mechanisms that you can have in order to create different kind of mimicos. So if you read it, it looks pretty much like a software architecture document, but it has some additions in the document then in which it shows that this is not only for one single architecture. You can customize some parts, like either in the software part or in the deployment part. So this information would allow them to have like a family of mimicos without having to create a new architecture every time.
Yes, and the other reason for the reference architecture is to put the base to create a product line, because it's possible to create components from the reference architecture for create product in fast way.
Yeah. We didn't get to the point of defining a product line for them because of some issues that started in the middle. So we started with the reference architecture. It was supposed to be a product line in the end, but we just stopped in the middle of the way for this specific project.
Any other questions? Still have some time. All right, thank you so much, Andres. Thank you, Alejandro.